the CTO of Digital Harmonic, and today I'm going to talk to you about two of our technologies that allow you to revolutionize mission performance while keeping the sensors you already have. We have three main products at Digital Harmonic. I'm going to talk to you about two of them. The first is Pure Pixel, which is an across the spectrum, bump in the wire video enhancement capability that will remove atmospheric problems like when you're collecting video at night, or fog, rain, haze, etc., as well as improving focus and other collection problems to maximize the information potential out of your imagery in real time with very low latency. And the second one is Keyframe, which is a client-side capability that allows you, with the existing encoding pipeline for any video streaming application, whether that's video on demand or live, reduce bandwidth by 20 to 80% without any loss of quality. Our backstory is actually pretty interesting. We were founded by Paul Reed Smith. He's a famous guitar maker who, in the early 2000s, along with his father, Jack, they were trying to build a guitar synthesizer. And the major problems at the time with guitar synthesizers were that they were terrible, but really it centered around latency and on the ability to pick out the notes. So you would pluck a note and it would get the note wrong, especially if you're playing a chord or anything complex. It wouldn't be able to center in and figure out what was going on in that signal. And secondly, it would take too long to do it. So it would play too late and it just wouldn't sound right. It wouldn't feel right. And so they found and invented a novel way to go use the harmonics to go very quickly. So if you play a note, an A at 440 hertz, or 441, I guess, if you're a violinist in some orchestras. But if you play that note at 440, less than a 4,000th of a second later, they pick up that the A was played and they can send it out. So they solved that latency problem using something called fast find fundamental, an entirely novel technique. And then to solve the problem of that, getting the precise note, he and his father went in and used fast Fourier transforms in a completely novel way and formed a groundbreaking ability to, and I'm going to use a term that's mostly used for imagery processing. It's an entirely visual term, blur. They were able to take audio signal and de-blur it. So they have this technique that back in the early 2000s that they found to increase the frequency, amplitude, accuracy, and time accuracy of signal in real time with high compute efficiency. At that point, they abandoned the guitar synthesizer because the potential of this new techniques, both of them, was so fundamental that they had to go see what they could do with that instead. I'm going to get into Pure Pixel. I kind of want to say, so I just talked to you about signal stuff, and now I'm about to talk about imagery. What's the relation? So Paul, it's not as crazy as it sounds that Paul and his dad came up with this. First, his dad was a career mathematician supporting the US Navy, and Paul, frankly, just has the best intuitive grasp of math and physics of anyone I've ever met. And so Paul was able to extrapolate the sameness of the signal world, that audio, acoustic, whether that's radio frequency or whatever it is in the acoustic or EMAG spectrum, electromagnetic spectrum, sorry. He was able to extrapolate that, improving the precision, so deblurring effectively, and bring that over into the imagery and video space. And that formed the foundation of both of our products that we've been building on for quite a long time since, and added a lot of significantly new foundational capability as well. So I'm going to talk about Pure Pixel. And Pure Pixel is that bump in the wire, right? So what I say, no matter what your mission is, so in this case, I'm going to talk you through some humanitarian aid disaster relief cases like firefighting. I'm going to talk through just a bunch of different use cases for Pure Pixel. But the commonality, and which is common from my past, is that human that is doing the mission, right? Unless they're a wedding photographer on the side, imagery enhancement, video enhancement may not be their gift. It may not be something they're skilled at doing. And regardless of whether they're the best at it in the world, for a lot of missions, especially real-time ones, like you're trying to find people on the ground, like firefighters through smoke or anything like that, or keep people safe, you don't have time to spend 30 seconds on every frame and get it tweaked up so that you can actually use the video that's coming back to you. And secondly, there's the issue of it's not their mission. So whether they are skilled at video processing, their job is actually whatever the job is that they're doing and not it. So we focused, the shortfall that we found in the market and the environment was that there really wasn't anything that was A, completely automatic, and B, doing so in a good enough way to actually be useful to expand mission performance. And so we built Pure Pixel, and I'm going to talk about it now. So at the top left, you have an out of focus image. This is an airborne looking down at the ground. There's a person in the trees there. Then you have a fire department in the middle, which is visible light. So that says EO at night. That's electro-optical. That's just a visible light camera. And so it's looking down at the ground. And the reason why they're flying this drone is, one, to look for secondary burns, secondary fires, and secondly, to look for, make sure people are staying at a safe distance away from the fire. You have some satellite imagery looking through cloud and haze in the top right, staring at an intersection. This is just a safety case, but essentially just staring at an intersection, looking at the people and vehicles through fog and rain. You have a high resolution body camera trying to look through smoke. And in the bottom right, you have an iPhone camera taking video of a rally race looking through dust. So these are common obscurants or common things that stop you from being able to collect information and perform some task on this video. In real time, sub 30 milliseconds or sub 30th of a second, door to door on all of these video feeds, PurePixel is going to do this. So it's going to take away the clouds and haze. It's going to focus up that image of the person. So it's very easy. And more of what you'll notice is these images, unlike these, I may be able to achieve some level of success and see some people in this. And this one, not so much. There's actually a person walking across the street right here, but which isn't visible at all in the prior imagery. But it causes a human to stare at this imagery is burdensome. That's why it's called cognitive burden, I guess. But the point being, even if they could achieve the mission, it's taxing for them. You're having to do work. And moreover, you're having to do work that isn't the job that you shouldn't have to do, that a computer should be able to do for you. One very important note, I'm going to talk a lot about machine learning during this, but of most importance, there are times when machine learning or data trained algorithms in the current sense of machine learning, so any data model, data trained algorithm like random forest, Bayesian networks, the data trained kind, and specifically deep learning neural networks or generative adversarial networks being a kind of deep learning neural network. They're phenomenal for a bunch of different reasons. And, we have them on our iPhones to do night mode. That's a fantastic thing to clean up that imagery. However, what that is entertainment, like photo editing, things like that. The use of these techniques, these data model techniques, is not admissible in an information extraction regime. And so anytime you're trying to do a serious mission where you're trying to say, even if it's just a surveillance camera where you're looking at a parking lot and trying to make sure your employees are getting safely to their cars at night. In all of these cases, these neural net based techniques just aren't being, they aren't useful. They aren't usable in that for two major reasons. Number one, they carry with them, they're data trained, and they carry with them the biases and the incompleteness of that data they've been trained on. And secondly, they're generative. So we take measurement, we use brute force mathematics only to go process that measurement and try to extract as much information as we can, but we don't add any more information. We just extract what's already there. Whereas generative techniques, like generative adversarial networks right there in the name, or deep learning random forest, any data trained technique is generative in nature, where it's going to do a thing called in-painting or hallucinating information, where it postulates what might be there based not just on the measurement it's receiving, that video feed, but also based on the data it was trained upon. So it's actually taking the data that it was been trained on, taking the measurement and saying, well, what do I have in my data set that looks kind of like this? And then it's going to insert information, which is great if you're trying to make a prettier picture or you're trying to do something for entertainment purposes. But specifically as it pertains to touching the pixels and then trying to show that to a human being, that there are some challenges there that would have to be overcome before that would be usable in a serious application. But that said, I'm then going to spend the rest of this time showing you how phenomenal machine learning is at a great many things, from scene recognition and event identification all the way through object detection, where you put bounding boxes around people, vehicles, etc. It's absolutely fantastic and usable in every regime of using in that way. But specifically as it pertains to video enhancement, we draw the line essentially entertainment, but we can't really use it for serious applications. So, all right, like I said, bump in the wire. One of the most important things, and we ride completely, PurePixel is based on the CUDA architecture. As actually every piece of tech I've built for the last 12 years has been entirely based on CUDA when I need performance. But the most important thing here was this needs to run at scale. It needs to be able to run down if you're at the edge in a laptop. So I'm actually running this demo on a Dell Precision 7740, but on a 7750 with RTX 5000, we're going to handle 2 real-time 1080p 30 feeds, and we'll handle up to 6 standard def feeds in real time without taking the box down. So we always know this video enhancement is extremely important to make it so that you can perform a mission that you couldn't have done prior. However, we're not the mission, right? Just making the video better that enables you to go do whatever it is you already wanted to do in the first place, and maybe weren't able to do before, but you always intended to. So we're just part of it. So we have to be very respectful of being in that, what we call multi-tenant environment. We want to be good arbiters of making sure we're not stopping all the other software that you have running on that computer from being able to perform its function as well. So we try to be as thin as possible. We try to just be a bump in the wire and have really good interfaces that allow it to support. It runs on Windows and Linux. And like I said, the most important thing is it is completely automatic. So you as a human don't have to futz with the knobs or do anything or pick your dial, because there's just no time for that in most real-time scenarios. Machine learning. So this is a great thing. Because of the way that we do our technique, the unique way to remove dust, we're able to take machine learning models that are, say, trying to find people, vehicles, et cetera. We're able to take those without retraining them and have them work in areas where they weren't trained to work. So I'm going to show you a couple videos, and then we'll talk about the performance. So this first video, what you're seeing on the left is the rally race in dust, which you'll notice if you take a look at the background, you'll see all of the people. We're extracting all that content so that you can clearly see the people in the background, and that will enable, for example, I'm going to show you YOLO v4, you only look once, version 4, is a standard, it's a commodity off-the-shelf object detector. So it's a machine learning based thing that puts bounding boxes around people, vehicles, and 80 other classes of object. It was trained on a thing called Microsoft Common Objects and Context. So it's just a commodity detection set, not a lot of trying to stare through dust, clouds, haze, fog, rain, snow, etc. So it was really just built to do clear weather detection. So here's what it looks like. And now I'm going to put boxes around things using YOLO. So you'll notice on the left, you have a bunch of, and I'll just pause it here for a moment. You'll notice on the left, you have challenges detecting any of the objects. I'll try to find a place where it's getting something, but on the right, you're detecting the vehicle, you're detecting a lot of the people. And so your detection isn't perfect on the right because, that's fine tuning. You can then go retrain based on this new information. But what I will say is the difference between the left and the right with regards to detection performance is just phenomenal. We're taking sub 10% probability detection per frame and taking it up over 70% in a lot of cases without having to retrain, do the costly process of remodeling the algorithm, doing that kind of stuff. All right. Some more examples. One of the most important things about an automated technique and why we try to avoid the human having to be distracted by processing is you get often very dramatic changes in the environment. You're doing your mission, everything is fine. You're looking at a road, you're watching traffic go by, and then you turn west at sunset and you're going to have a bad time because of the glare. And so we'll automatically fix that, we'll correct it and get you back all that information. And so you can pass it to the downstream things. When we do our job well, all of the downstream human operations, machine learning, we're mitigating, we're correcting out all of those atmospheric problems and all of the problems in the collection, whether it was blurry collection. We have a phenomenal deblurring capability, as you'll see in a moment. But to doing all of those things that we do uniquely well so that the downstream stuff doesn't actually have to change and doesn't have to be modified to handle all of these cases. That's when we're doing our job right. Same thing, here's that same fire scene, so you can just kind of see how it works and how much easier it is to detect, so you can see, just get a lot more information content than was available just looking at the main scene. So same thing, I'll just point you to the person walking in the back here. This is a scene where, and if you go to our website or you go to Vimeo, you'll see a much more dramatic version of how we process this. This is actually what a human would look at when our system is running automatically, and it's much more subtle. And the reason for that is, again, cognitive burden. We can increase contrast or extract information and do all these things and make it almost look like cartoonish or a little bit uncanny in how it's presented. And it increases the signal noise ratio to a point where it's frankly over long haul would be uncomfortable for human beings. So instead what we do is we produce this, I'll say, softer result where we're not maybe pulling quite as hard as we can, but we're doing it to the point where it's still pleasing to the human eye, and long periods of watching won't tire the human eyes out quite as much as when we take it to the cartoon level that we can. So, and that's one of the things about a control system, about a thing that's reaching in to automatically do this work, is the most important thing is, after you make it work really, really well on degraded video, the other two important things are you have to have restraint. You have to know when to stop. And secondly, don't break video that's already good. So we probably spent just as much time making sure we don't overdo it as we did building a lot of the algorithms in the first place. So one more thing I'm going to show you is low light video at night attached to a vehicle. So in this case, you have a camera attached to the back of a car driving down the road. And if you'll notice on the left versus the right, in real time, automatically, we are significantly increasing the amount of information you can pull out of that scene, which is extremely important for human safety. And you'll notice when we run the detector on it, completely not retrained, just the same exact detector, you're seeing a lot of people, you're still detecting those people on there. And that translates to the better part of 4, 5, 6 seconds of detection at night of pedestrians in the roadway, which is extremely important to the protection of human life. And giving these algorithms, if it's an autonomous vehicle, or even just alerts, safety features in human-driven cars, the more time you give it, the more decision time you give human beings to do something to avoid a critical event is absolutely key. And I will say, we've also demonstrated this, so not just in ground-based vehicles, but in commercial aircraft. They have systems called enhanced vision systems, or EVS systems, which are cameras, multi-band cameras that are attached to the aircraft and that help them in degraded visual environments, so fog, rain, snow, night, etc., degraded visual environments to find the ground and the runway so that they can land safely. And we've demonstrated the ability in these rough environments, like extremely low visual range environments, to where we've given back anywhere from 3 to over 10 seconds of decision time where we see the runway using our processing completely automatically. And so that, just from a safety perspective, is just such a huge deal, trying to make aviation as safe as it can possibly be, but also let that plane land on the ground on its tires. So that was Pure Pixel. And if you think about it, Pure Pixel's job fundamentally is to improve, clean up, and make all downstream processing, whether that's human doing operations or machine learning doing some level of inference or decision making to suggest to operators based on that. And that works down from the laptop grade through the data science workstation, the 7920s, all the way up through the data center servers. It's already pre-built and ready to go. And I joked at a previous talk where it used to be that hardware was absolutely the hardest part. And for us, that would be true as a tech company who focuses on software. The hardware would be a problem, but our partnership with Dell has just taken that completely off the table. So it removes all the guesswork. It's just like buying a hard drive off the internet. You just go get the system. It's already pre-built. It's already pre-configured. Everything is completely ready to go. And you have that multi-tier support just baked in that has been wonderful for us. And I don't have to answer the phone as much. So I'm deeply appreciative of that. So now we'll talk about the second. So if Pure Pixel's job is to make video better, is to extract more information, Keyframe's job is to get it from point A to point B with significantly less bandwidth. So if the video is foggy going into Pure Pixel, we're going to fix it. If it's foggy going into Keyframe, we're just going to let you send that same foggy video, or actually it's better quality. We're still going to improve it because we can't help ourselves, but it'll still be the foggy video, just significantly less bandwidth to move it. So how much bandwidth? So for 1080p and 4K in normal living room environments where that's a tablet or a PC or what have you, we're going to drop bandwidth by anywhere from 20 to 80%. Typically, we can send excellent 4K in about the same bandwidth it takes the rest of the world to send excellent HD. And we do that without building an encoder at all. We're completely on the client side. So whether you're doing AVC or H.264 encoding, HEVC or H.265 encoding, VP9, AV1, all of the modern codecs, we are codec agnostic, and we provide these levels of gains across all of them. And the reason for that is kind of twofold. Number one, all of these codecs trade compression, so they get lower bit rates by inducing blur. They're not inducing blur, they're really just removing high frequency content. That is what takes the most bits to send down the wire. But we're able to reduce all of that and recover it on the other side, but we don't have our own encoder. So it's still completely standards conformant. It's still just the exact same video. We just ask that the sender side crank down their bandwidth. And this works both for live streaming, live low latency streaming, and video on demand or pre-recorded content. So how it works. So the encoders, we can hook our optimal bitrate selector up to it for any given video stream or feed. Or in the case of some of the larger companies like a Netflix or Hulu, they're already going to have a video quality based measurement capability. So we would just fit keyframe into that so that they could pick what the optimal bandwidths are, or they could just say, if it's 4K video, go ahead and just take a 50% cut off of it and we'll recover it on the other side, especially at good and excellent quality. But how it works is we take advantage, we just sit on the device side, we take advantage of the decoder that's already built in. If you have a phone, it already has a video decoder built in. If you have a computer with an NVIDIA GPU, you already have a world-class H.264 and H.265 decoder and encoder, but you have a decoder built in to your card that's running in an ASIC. So application-specific integrated circuit, it's running extremely low power, very efficiently, and most importantly, very, very fast. So take advantage of that. Us trying to build another encoder-decoder pair, it just doesn't make sense at the scale of the market. And moreover, it doesn't make sense. You're not going to put that in an iPhone because it's going to just drain the battery incredibly. So we allow the decoder to do what it does. We get handed the pixels. We then upsample them and perform the real-time video quality recovery enhancement and then push it to the display. So we get pixels, we just give back pixels at whatever size they're supposed to be. And we do so very efficiently. For example, we've run this on 6 to 8 different Android and iOS devices. And over the course of an hour of video playing with or without us, there is no appreciable, it's actually negligible battery drain differential between the two. Sometimes, in fact, there's more battery left over while we're running. And that's really because we take away the upsampling that had to be done already. We're doing it for them, and our process is incredibly efficient, but it's also uniquely advanced. There's it has no peer as far as we know. The other option, if you don't have control over those devices, like in a Netflix, Hulu, or any of the cable companies, if you don't have control over your app or over the device on the receiver side, and this could be true, by the way, for if you have a bunch of, if in a corporate environment or a government environment where you have a lot of video cameras out there, whether you're, again, looking at critical infrastructure or you're just looking at a campus or looking, trying to bring that back so security forces can maintain safety on those campuses. We offer a Dell appliance that's essentially a matched pair that will allow you to take in the source video, we'll knock it down in bandwidth, do the encoding and everything, push it over to the other side to our other appliance, bring it back up and send it into the network at the receiver side so they can work like they always did. Nothing has to change at all, and we solve the bandwidth problem. Because in a lot of cases, if you have a moderate sized campus or a large facility, we may be talking hundreds to thousands of cameras, and the ability to say, the bandwidth that I can send, say I have 800 cameras, or I'm actually downscaling the number of cameras I need just because of the bandwidth that I can afford. If you're sending, call it N feeds today, if you're sending 100 feeds today with a given bandwidth, it's depending on the video type, it's very possible you could be sending 200 to 300 video feeds tomorrow with the same or better quality. Okay, so these incredibly nerdy slides generally show you, so VMAF is Netflix built this phenomenal video quality metric called VMAF, so Video Multi-Method Assessment Fusion. And while it's not entirely perfect, it is absolutely the best that there is at measuring human perceived quality in video. And so it's a scale of 0 to 100, and 97 is considered excellent, 95% is considered pretty darn good. And so just generally when you're looking at this, blue is standard encoding the rest of the world, and green is where we are. And so this is at 1080p with H.264, VP9, and AV1. And what you should notice is the percentage that we improve is actually better with the more efficient VP9 and AV1 encoders. And more importantly, we can send at excellent quality and less bandwidth than the rest of the world sends good quality. Here's one for 4K, but I'm actually going to skip over to this and show you a couple examples. So not taking you through this entire slide, but of important note, what you're seeing here is bitrate over in the x-axis, and on the y-axis, you're seeing quality. And so we're up, obviously we want to be at higher quality at lower bitrate on the left. And that's where we are with the purple line. And what you'll notice is a video on demand, or when you can do the 2-pass encoding or be as efficient as possible with how you do the compression, we're achieving excellent quality for 4K around 14 megabits a second, where industry standard is going to be somewhere between 32 and 40. So we're going to drop anywhere between 40 and 80% on that video feed. And then in a live environment where you can't do that multi-pass compression, we're going to still drop. We're going to be somewhere between 10 and 14. The rest of the world's around 40 with HEVC live. Now, granted, some of these cases were, using commodity encoders, and maybe they weren't tuned the best way. We have also done this on several industry standard encoders with essentially tried every knob, turned every knob, made everything go as efficiently as possible. And that's represented in what you kind of see. And that will show you its scales. So say, for example, you can do it in 20 with a standard encoder, or you can do it in 20 with a special encoder. We're probably going to get there in somewhere between 5 and 10 megabits versus the 20 megabits of that system. So the gains remain all the way down. So this is living room viewing, and the other case is mobile viewing. So in mobile viewing, it's not 20 to 80%. It really tends to be 18 to 35. And that's really just in deference to the fact that I'm not looking at a 4K monitor. I'm looking at a 1080p or a smaller pixel content. And it's generally speaking farther away from my face. So I'm seeing less of those pixels. So it's hard, it's easier to look like good quality. It's easier on a mobile than it is in a living room environment, but we're still achieving 20 to 35% gains in every video that we tested. Especially and it gets better as you go, like for VR, for example, or the more efficient your encoder, we actually get more gains. So Pure Pixel, we've mostly focused on the federal environment, but there are many applications. Actually, before federal, we did some research into the healthcare industry. We took adult male chest X-ray at full radiation, and then one with 80% less radiation, and we were able to, just running it through Pure Pixel, we were able to demonstrate increased diagnostic capabilities with our processing on that image, vice with 80% less radiation, vice the standard one, which is a huge, from a health perspective, that's a huge deal for the person being radiated. But furthermore, it's a case where the results being achieved or being demonstrated by machine learning in the healthcare industry, enhancing X-ray images. There's a huge difference between detection and enhancement. Detecting things in X-ray images, I'm completely for it, because you can, a radiologist can independently corroborate that with the measured X-ray image and say, yes, I agree with that. Yes, that's right. Or you can use some other form of corroboration to get it. But the simple fact is, if you're going to modify the pixels with a generative or a data model, data trained algorithm, that's fraught, because again, we're in that information extraction space. So we just want to make sure we don't use any of those techniques for that. And so I already talked about the remote and airborne operations, but there's a huge usage of Pure Pixel available in non-penetrating inspection, critical infrastructure protection, those kinds of things for oil and gas, as well as state and local municipalities, whether that's trying to find lost hikers, looking through degraded visual environments. So if it's a clear sunny day, well, congratulations. Hopefully you enjoy it. But if you're doing search and rescue on a clear and sunny day, and you have complete clarity and good collection, then Pure Pixel isn't needed. But usually it turns out bad weather makes a lot of the bad things happen, and so that's where we really shine and show what we can do. And on the keyframe side, beyond the over-the-top streaming and the cable companies, pretty much anywhere video has to move from point A to point B, we have yet to find a case of video where we don't significantly reduce the bandwidth. And for anyone who's pushing stuff to mobile, who's having to pay for that bandwidth, Keyframe has just a small software library that's not going to require more compute. It's not going to require anything other than just software modifications of how your client works to display the video. It's gonna have a very outsized impact on, it's not really gonna cost you money. It's just gonna save you money. So thank you for taking the time. Again, I'm Mason Barron. If you want to learn more about Digital Harmonic, it's digitalharmonic.com. And thank you again to NVIDIA and Dell for being phenomenal partners and giving us this opportunity. Take care.